Okay, we are recording.
Okay, this rock here is a beach sand. This was a sandy beach about 350 million years ago. How do I figure that? Well, first, this is almost a pure quartz sandstone. As a matter of fact, it's so pure that it's quarried in this area as a source of silica for making glass. No organics and very little iron in it. Iron is not good in glass because it gives it color, and they want their glass to be colorless. How do I know there's not much iron in it? It's white. If it's iron, it's probably reddish or brownish or yellowish.
Like this one?
That one has a little bit more iron in it, yes. But a lot of this is almost pure white. And if you look at this closely, the grain size is fairly fine-grained sand. And if you look at it under the microscope, you can see that it's 99% plus quartz, almost pure silica. How do I know it's a marine beach? Because there are holes in this rock that are the remains of fossil seashells that have been dissolved away, leaving shell-shaped holes. The shells themselves, by the way, is an organism called a brachiopod, which you've probably never heard of. In fact, even if you took biology, you probably never heard of it. If, however, you took a paleontology course, you certainly would have heard of it, because during the Paleozoic, and these are Paleozoic rocks, the brachiopods pretty much were the same as the mollusks today. They were one of the major forms of life in the ocean, and they lived exactly the same way that clams and such do, by straining food from the water. So this is basically a sand with seashells in it. And if that doesn't give you the evidence that it's a beach, I'm not quite sure what would. At this particular period, these are marine rocks. There was no big influx of sediment at this time. This is before the collision that caused that big flood of clastic materials up there. Now, this is a clastic rock, but since this is a clastic rock that's almost pure quartz, that means all the unstable materials, the feldspars, the micas, the pyroxenes, the amphiboles, all of those rocks are long since worn away by chemical weathering. And so only the most resistant rock remained, and it's here because the ocean was advancing in over the land here, and because the ocean was advancing in, the first thing that you get in an advancing ocean is the beach. The beach comes in, and as the ocean keeps coming in, the water gets deeper, and then you get the offshore marine stuff, still with a lot of fossils in it. So we can actually watch, as we come down in this direction, we're watching the advance of the ocean with time. Because here, we've got the beach, we're going to go in there. Since we're going in this direction, we're getting younger and younger rocks. And the rock sitting on top of this is a marine, very calcareous siltstone or shale. As a matter of fact, whether you call it a limestone or a shale, two geologists might give different names to it, because it's in the middle. It's a very shaly limestone or a very limey shale. Okay? If you search through these rocks here a little bit, you can probably find some of the fossils. Do you have any?
Maybe something right here?
Let's see. I don't think that is, but cavity on this side, that's the hole left by a shell disappearing. Mm-hmm. Yeah, this too. These cavities in here.
Show it to the camera.
That cavity there is left by the solution of a shell. which means that the water trickling through this rock was slightly acid and it dissolved away the calcium carbonate in the shells and just left the holes. So you don't actually find the original shell here, only a shell-shaped hole. The brachiopods, by the way, are still around today, but today you have to really hunt for them because they've been almost replaced by the mollusks. Probably almost nobody has ever seen one who didn't actually go looking for them. I have collected them, but that's because I go looking for them and I know where to look. Okay, we can then go back up past the car there. There's a trail leading off to the right, and we'll get to look at our next rock at this same stop.
That's the one that has the sand and the rock on it, right?
Yes, we go through.
It's close.
Stone together, and you've got the original sand grains here now. This is the same way the beach looked, same sand that the beach had 350 million years ago, except now it's sand again. It's come apart.
Sand to sandstone,
However, we're going a little bit
sandstone
further.
to sand.
You can see the bedding in the sandstone here too. Again, it's dipping back this way.
Recognize it.
Because I've seen them, I've been looking at them for 60 years.
Oh, wow.
That's why. And they look like lifesavers. Little tiny lifesavers, little round, where was it? Ah, that one there. And that one there. They're little round things, like a tube, like an inner tube, or a tire.
Yeah, yeah,
But
yeah.
if you see the whole animal, you get these little things piled on top of one another, like a pile of tires stacked on top of one another. And then the animal, the starfish, lives at the top
the head.
and collects food. Well, it doesn't really have a head,
Okay.
but it has arms,
Yeah.
and it is related to a starfish. And 350 million years ago, it was one of the most important forms of life in the ocean. They still exist today, except that they're only in a few places in the world in the deep sea. So you don't get, nobody gets to see them today. If you were here 350 million years ago, it would have been as common as starfish on the beach today. But since this has a fair number of fossils in it, I'll take it back. Now, what kind of rock is this?
Limestone?
Well, it's actually in between. It's called the Needmore Shale, but it could just as well be called a limestone, and individual beds in it are more limestone than shale. This one I suspect is probably more limestone, but
Maybe. Yes.
See the fizzes?
Not quite as much as some of the other stuff. It's a very impure limestone
Okay.
or a very lime-rich shale, whichever you like. As I keep telling people, we like to put things in nice, neat categories and say it's either this or that. Nature doesn't work that way. Okay, you can see the bedding here again very nicely. The rocks are dipping back in that direction. So, as a matter of fact, that's dipping steeply enough that it could be turned over. That could be overturned. But it isn't. In this particular case, the reason I know is because we've got younger rocks over in that direction. Those were Mississippian rocks there, as you could tell if you were able to find some of the fossils there. There are a few fossils at the outcrop, but it's enough to identify the age of the rock. These identify the age of this rock as being Devonian, which is the period before the Mississippian. This is the middle of the Paleozoic, not the late Paleozoic. This is period number 4 of the 7, so it's right in the middle. This particular, the sandstone that we saw back up there, by the way, you can follow that all the way down from New York State, where it's called the Oriskany Sandstone, all the way down into the southern Appalachians. That's true of many of the rock units that we get to see, that they run the whole length of the eastern part of the country, all the way down, in some cases, to Alabama. Usually I spend a little bit more time here because usually it takes me longer to find the fossils. However, in this one, the first rock I pick up is full of fossils. Not very good ones, not very spectacular ones, but they are fossils. And I think I saw one here that was actually pretty good. Oh, I wonder. No, probably not. You could find trilobites in this too. I never have, but this period did have.
Fossil too, or is only?
Oh yeah, that's maybe even better. But yeah, that's full of fossils.
Oh wow.
And I'll take this and add it to the collection in the room that I have. Okay. So this is a period in between the mountain building periods. This is just before the collision of, quote, Madagascar with North America, the one that caused all the clastic sediments from our previous stops. This is older rocks, and it's before the collision, before the Acadian Mountains, after, but later than the first set of mountains. Okay, let's head back then. And now,
I found a seashell.
oh yeah, that's a very nice brachiopod.
Let me see. Can you hold it for the camera and point to it?
Oh, you had it here. Ah, right here.
I think
You can see the ridges on the shell.
Okay. Oh yeah, I can, but not with my sunglasses on.
It doesn't help. Here, do you want this one?
Yeah.
Oh, I found.
And it's going to fizz. I won't bother putting more acid on it. I already did it. But
So
that
neat.
is a nice piece of fossil rock. And if you give that to a paleontologist, an expert in these fossils, he'll be able to tell you very closely just how old this rock is because of the fossils in it. Because the fossils change with time.
I think I found a rock that was like full of.
Oh yeah, that absolutely full of fossils.
Yeah, it was just like laying there.
Well, yeah, all of
Too
this
big to
rock
carry.
has fossils in it. Some of it richer than others.
Wow.
And a paleontologist would come in here and have a lot of fun trying to pick out fossils. One way you can get these, by the way, is you can put this rock in acid, and if you get the acid just right, sometimes you can dissolve the fossils out.
Oh wow.
Yeah, paleontology it's a cross between geology and biology. And of course, much of the evidence for evolution comes from rocks like these, because you can see the change with time. Anyone want to have lunch?
Yeah.
Let's go have lunch.
Noontime in 20 minutes. I hope it's not Wendy's.